working out a confidence interval for the population Poisson mean lambda using a normal approximation. We're going to use a normal approximation to the Poisson distribution with an estimated standard deviation. So what we calculate is an approximate confidence interval for the Poisson mean. Lambda hat is the total number of events recorded. It's an estimated value of lambda, hence the hat. The formula to calculate the confidence interval is not given in the formula book. This needs to be memorized. Once this confidence interval has been calculated, you may need to make some adjustments according to the unit interval required, but the adjustments are made after the calculation of the confidence interval. A shop sells 48 new bicycles over a period of 12 days. So this value here, the 48, this is our lambda hat value. And the interval is 12 days. So we're going to calculate our 90% confidence interval for a period of 12 days first. Once we've done the calculation, then we can scale the calculation afterwards and modify it for 1 day. The interval required is for 1 day, but the evidence given here is for 12 days. So the total evidence given is 48. That value is lambda hat, and in the formula it goes here and here. For a 90% confidence interval, we put 90% in the center of the normal distribution, with 5% in each tail. The cumulative probability to the left of this line is 95%. So we look up p equals 0.95 from the tables, and we get a z value of 1.6449. And because we have a negative and a positive z value, it's plus or minus 1.6449, which goes into the formula here. So now we have everything to calculate our 90% confidence interval. So the confidence interval for a 12-day period is given by this. So if we calculate with the minus first, we get 36.60, and then repeat the calculation with the plus, 59.40. So this is for a 12-day period. In the question, we're looking for a 90% confidence interval for the mean number of bicycles sold per day for 1 day. So now we need to make some adjustments. So this is for 12 days. For 1 day we need to divide both of these values by 12. So this is the 90% confidence interval for 1 day. So there's a 90% chance the value of lambda, the population mean, lies between 3.05 and 4.95. There's a 10% chance the population mean lambda lies outside this interval. The interval calculated is only approximate for 2 reasons. First of all, the normal distribution is being used as an approximation to the Poisson distribution. The second reason, the standard deviation used is only an estimate. And the standard deviation is this part of the formula. This is the estimated standard deviation, this value here.